So D to A converter, yesterday we have discussed there are two types are there, and one is a weighted binary. We have binary weighted resistors. If I take one as a R, another as a R by 2, R by 4, R by 8, binary weighted I am taking, and these are switches B0, B1, B2, B3 just to represent 0 and 1, and supply voltage 5 volts I am giving. So no need to copy, all these information will be available, we can copy down later. And what voltages I'll get? A negative voltage. Last class also I told, because I am using a inverting terminal. Even you might have observed here, I am using a inverting terminal, hence output will be negative. I am giving a positive input voltage. So now, so the number of binary bits, this we have discussed already, a 4-bit converter, because 4 bits I am giving, and 2 raised to 4, totally 16 combinations will be there. I can switch on, switch off, I can have a 0 or 1, B0 up to B3, total 16 possible values I can give. And even some books they may explain R, 2R, 4R, 8R like that. Instead of multiplying, I have divided. Anything is okay. Okay, in some books you may find like this, but concept will remain same. So now this is already discussed many times in your previous classes. The total current flowing here will be the sum of all the currents flowing if it is connected. Then IT equal to what? Total current, I1 plus I2 plus I3 plus I4. And this is grounded, hence it is a virtual ground, hence current is given by I1 equal to whatever the supply voltage is there, 5 volt for example, is considered divided by R. IT equal to V by another resistor I have R by 2. I3 equal to V divided by resistor I have R by 4. Like that I have a I1, I2, I3, I4 values. Simply I am filling these values and I am rewriting V0 equal to. And in this B0 and B3 up to these I may have a 0 or 1 combination, means connected, not connected. And now by filling the values, okay, these values, resistor values you know, for example RF is a 1 kilo ohm, and R you can take 10 kilo ohm, R by 2 5 kilo ohm, fill this, and you can vary this combination B0 to B3 as 0 and 1, you will get these voltages. And again I am getting a negative voltage, reason is it is a inverting terminal I am having. Then we have a drawbacks. Reason is, in this, if I take a 8-bit, for example, converter, that time I need 2R, 4R, 8R, 16R, like that I need a resistor, which are very difficult. High R is very difficult to fabricate in the IC, and finite resistance of the switch also comes into picture if I take a lower resistor. So this is the one point which you have to remember as a drawback for this binary weighted resistor. And one more we have a D to A converter with a R to R ladder, we say. It looks like a ladder. There is a reason in most of the book they say it's a R to R ladder. So binary inputs are simulated by again B0 through B3. I am connecting B0, B1, B2 either connected to ground or connected to the 5 volts, or connected to the ground, connected to the 5 volt. In this case B3 is connected to the plus 5 volt. All are connected to the 0, or you can say connected to the ground, and always I can have any choice 0 or 5, 0 or 5, like that I can get again a 2 raised to 4 combination, 16 combinations I can have. And based on this, for example, in this case only this B3 is connected, observe carefully. So in this only B3 is connected and remaining are grounded. So I have to find out RTH left of the switch B3 I had to find out. Try to observe carefully and try to understand. All of you know RTH you have found many times already. So observe carefully, see the screen properly. Now I am considering only this 20K, 20K. So this 20K, 20K when they come parallel, hey, observe here, it will become 10K. Again this 10K will come series with this 10K. Total will become 20K. 20K, again this 20K will come parallel. It will become how much? 20K, 20K will become 10K. Again this whole 10K will become series with this 10K. It will become total 20K. Again 20K will come in parallel with the 20K. Total it will become how much? Again this becomes 10K. Try to understand, it is very simple. And now I'll get this 10k and this 10k ticket, total 20k I'll write, and remaining this 20k, this 5 volt I'll keep as it is. This is the equivalent circuit. And for this we have a RTH left of a switch B3 is a 20 kilo what we got. The current flowing through the RF is a 5 volt divided by 20k is nothing but you will get a 0.25 milliampere. So that voltage what I will get a minus 5 volts I will get. For all the possible combinations you can calculate manually also, and you can make a table. So if you make a table, it looks like this. For example, this is a say 6. I am taking only these two as a 1 1, remaining two are 0 0. I will get a minus 3.750. When all are connected to 5 volts, that time I will get a minus 9.375. Actually, you are supposed to do this experiment in the lab. So that time you are supposed to calculate filling the values. This is a 0, 1 or 5 volt. So you will calculate manually, and practically you will observe and you will compare practical values with the theoretical value whatever you have calculated. This you are supposed to conduct the experiment in this particular semester. And now coming to the next, this is how manually, earlier we were using a LCD projector, overhead projector, OHP we were using, that time it was written, how I will get a 2R, 4R, 8R, that discussion we used to write on the OHP sheet, and we were using that time. Nowadays LCD is available. Anyway, let us go to the next. We have an important another topic, PLL. So I want to discuss the PLL now. Give me 2 seconds, each one of you. So let us discuss this PLL. Try to understand. Anyway, all videos are already there in the YouTube. Even I will try to upload this also. Contained PLL operation, phase detector, VCO, PLL application we are going to discuss. It was first introduced in the 1930. Cost was very high, limited use was there, but because of IC technology, now PLL is available in the ICs, and because of that, whenever IC is there, cost will become very, very low. And these are applications we have: FM stereo decoder, motor speed controller, tracking filters, many FM demodulator, FSK decoder, generation of a local oscillator frequency in TV and FM tuners, frequency synthesizer, transmitter and receiver. Lot of applications are there for this PLL. If time permits, if it is there in the syllabus, 1 or 2 we will discuss. Then we will go to the now next. Many ICs are available in our lab. We have a 565. Okay. Signetic, we have 565 IC, and it's a block diagram. What we have blocks, a phase detector. Basically what it does, whatever these two inputs we are giving, Fi and F0, these two will be compared. If both are same, this voltage what it is giving phase detector will be 0, and based on the frequency difference, or you can say phase difference between the Fin or Fi and F0, voltage will be given. For example, above, if it is a F0 both, then 0. If it is above F0, some positive. If below F0 it is, some negative voltage will be given. Low pass filter followed by error amplifier followed by voltage controlled oscillator we have. So just go through, you have a maximum 30 seconds. Just try to remember. We have a phase comparator, detector, low pass filter, error amplifier, voltage controlled oscillator. These are the blocks. I'll wait for the 10 seconds. Just I'll explain today. I don't want you two people to copy down everything. Just try to understand. If possible, I'll share all the information with you people. So let us go to the next. Oscillator, everybody knows what it does. And what do you mean by voltage controlled oscillator? Basically oscillator. But oscillations are controlled by voltage, hence I call it as a voltage controlled oscillator. Its frequency is controlled by some input voltage, hence it is called as voltage controlled oscillator. Based on the voltage variations, oscillator frequency also varies. For example, I am giving a 0 volts here. This is giving you the F0. If this I change, instead of 0 volt, if I give positive and negative, this output frequency will also change either above F0 or below F0. The same thing is written here. If it is not equal to 0, then output of this voltage controlled oscillator will not be equal to F0. And based on this error voltage, this F0 will also change, either increase or decrease. What this phase detector does, it compares the F0 and this input, and comparing these two, error voltage, if a difference is there, these two frequency, error voltage will be given as an output that will be filtered and then amplified, then it will be given to the voltage controlled oscillator. Remember, we are discussing a block diagram, and many people are doing a PhD on PLL. Even if time permits, I will show you their emails. They have asked some of the doubts to me because they are doing a PhD on the PLL. They may take 5 years, 6 years for doing a PhD. Those many years they work on the PLL. Now we are not doing that much. Not even on subject also. Not even in one chapter also. Not in unit. Hardly in one subtopic we are discussing a PLL and try to understand basic working of a PLL. Output of the phase detector is a DC voltage. Low pass filter is used to remove any high frequency noise is there. Output of the low pass filter is called as a error, which is given as a input to the VCO. VCO output frequency depends on the error voltage. So if error voltage is 0, it is a center frequency, F0 will be there. Based on the error voltage positive or negative, the output of the voltage controlled oscillator either will increase above the F0 or decrease below the F0. This is the basic concept one should understand, that mathematically they have mentioned. If no error voltage, output will be F0 only. If error voltage positive or negative, based on that F will also change. Now PLL goes through 3 states: a free running state, capture rate and phase lock. It little bit many times students get confused. You can read it twice, thrice. Free running, capture, phase lock. Free running means center frequency you will be having. For example, F0 is a center frequency. Capture means it is a frequency at which output becomes equal to input. We call it as a capture. And anyway, these two words are mentioned in the next slide. Try to read it and try to understand. Lock range, capture range, pull in time. So the meaning of lock range is given here. Read it twice. The range of frequencies over which the PL maintains lock with the incoming signal is called as a lock. What is the capture, sir? The range of frequencies over which PL acquire lock. Maintaining is different, acquire lock. After acquiring, it will maintain. Please keep your mind in the class only. Try to understand because I am telling you in brief. Once if it acquires a lock, then it will maintain. So capture range is nothing but acquiring the lock. Lock range is nothing but maintaining the lock. To maintain the lock, first you should acquire. So these two words I want you people to read twice. Take 20 seconds. Read a lock range, capture range. So this is the way how we mentioned this is a capture range. The frequency range it is. This is F0, maybe 5 kilohertz, something like that. Above this is a 6 kilohertz, 8 kilohertz, 10 kilohertz. Below this, I have a less than that. How to find this capture range and lock range? This is one experiment actually you are supposed to do in the lab, and even you can do the simulation and you can check it. See, this is very important. Many people take a lot of time to understand this capture range and lock range. Try to understand within less time. So now let us consider. I am increasing the input frequency to the PLL from lower frequency towards a higher frequency. Means I am increasing, say, 100 Hertz, 1K, 1.5K, 2K, towards the maximum, infinity, I am increasing. So that time, I will get two frequencies. One is a FC1, FL2. FC1 is a capture range frequency. FL2 is a lock range frequency, FL2. So when I am moving from, say, lower frequency to the higher frequency, I can get FC1 and FL2. Means it will acquire the lock here, it will maintain the lock up to FL2. Try to understand this. It acquires a lock at FC1, I am increasing from lower to higher, it will maintain the lock up to FL2. Similarly, if I do reverse, so if I am decreasing from maximum towards a minimum, I switch down. Now I am doing reverse. What will happen, sir? So now I am moving from highest towards the lowest. That time what will happen? I will get a FC2 and FL1. This is the frequency for capture and this is the frequency for lock. So FL1, FL2 are lock range. FC1 and FC2 are capture range. So this video is already uploaded long back, and already more than 20,000 students have studied this, and I hope my students also might have seen, and if they have a doubt they can ask later. Now coming to this FL1, FL2 is a lock range, FC1 and FC2 is a capture range. Once if it captures, it will maintain the lock up to FL1, FL2. To get output equal to input beginning, the input frequency should lie in between the FC1 and FC2. एक बार FC1 FC2 के अंदर आ गया, then I can drag up to FL1 and FL2. In brief, I try to understand this. The same thing now with example we will see how many of you have followed. I'll come to know. Let us take the lock range and capture range. I'll give some input. So when I give some input, you should be able to say whether it is F0 or whatever the input I am giving, it is that frequency. Let us take, I am giving a FA. Whether the output will be FA or F0. You should type in the chat box fast. I am asking you FA, and I'll repeat once again one important line. To get output equal to input, always my input frequency first beginning should lie in between FC1 FC2. एक बार FC1 FC2 in between, if it lies na, I can drag up to FL1 and FL2. So now if I give a FA as an input, what will the output? Is it a FA only or F0? So Vinay Kumar told when FA is given, output will be F0 because neither it is in the capture range. Now let us consider I am giving a FB. Say when I give FB, whether the output will be FB or F0. Very good. Everybody is typing F0. F0 is correct because to get output equal to input, first I should reach either FC1 or FC2. Then only output becomes input. Otherwise, 9. So now let us take I am giving a FC. Okay, very good. I am giving a FC. Whether output will be F0 or FC now. After giving a FC, FC lies in between FC1 and F0. Now the output will be FC. Very good. Now I am changing it to some other frequency. Say let us consider FD I am giving. When I give FD, what is the output frequency? FD. Very good. Now if I give a FE, what is the output frequency? FE I am giving. Whether the output will be F0 or FE, there will be a small doubt. एक बार कैप्चर हो गया ना, up to L1 L2 I can drag. Remember एक बार कैप्चर हो गया ना, output input एक हो गया ना, I can drag up to L1 and L2. Because of that, now output will be equal to FE. Because already एक बार output equal to input हो गया है, I can drag up to L1 and L2. Now if I make a FK, beyond FL1 FL2 I cannot drag it. It will go back to the F0. अगर वो ज़्यादा हो गया ना FL1 से और FL2 से. Now can you tell what is the output after FK if I give the input? F0. Again it will come back to F0. Very good. Now let us consider another example. Now I am giving an input FK. What is the output? No doubt F0 because it is far away. When I give FE, what about the output? It will be F0 only because I have not yet reached FC2. FC1, FC2, in between only I should reach, otherwise output will not become equal to input. एक बार output equal to input हो गया, we can drag up to FL1 and FL2. Now I am giving a FD. What is the output? Can you tell now? Now I have given a FD. Output will be equal to what? Definitely FD because it is in between FC1 and FC2. Definitely output becomes equal to input. एक बार हो गया, now we can drag up to anything, L1 and L2. FC I am giving, automatically output will be equal to input, it will be FC only. Now after FC also if I give FB, whether output will be equal to FB or F0? FB because it is in between L1 and L2. एक बार output equal to input हो गया, I can drag up to in between FL1 and FL2. If I give FA now, what is the output frequency I will get? FA if I give, automatically it will become FA only. It will not get F0 because it is out of the lock range. So this is the way how I had to understand this capture range and lock range. Hope most of you have understood within a short time. Thank you. Now let us take FC I am giving directly. What will be the output? I have switched on. Input was FC. What is the output frequency? Is it FC or F0? Suddenly I have given FC. How to understand? If it is in between C1 C2 na, वो same रहता है FC. Very good. All of them they are typing. Now I am making D. now it will change to FD. Oh, FC1 FC2 के है एक बार सेम हो गया, then you can drag. कहाँ तक ड्रैग कर सकते हैं आप? L1 and L2 तक ड्रैग कर सकते हैं. Now FE, if I give the input, automatically output will become equal to what? FE, because up to L2 I can drag it. Now if I make FF, now it will not become up to FF, it will go back to what? F0. Very good, everybody is typing. Now if I make a suddenly, I switched off and I switched on, suddenly I have given a FB. Okay, it will go be F0 only because it is not in between FC1 and FC2. Very good, most of you have followed. Even if I give FA also, it will be F0 only because it is out of the lock also. First I should apply in between capture, then I can drag up to any lock range. This is the basic concept for now. Last, okay, I am applying FC. Output will be what? FC, I am applying FC only. Very good. FD I am making, I am changing. After C I am dragging to D. What will be the output? FC, then I am dragging to FD. No doubt output will be FD. Now I am making E. Automatically it will be FE only because it is within the lock range. Then I will make a F. It will be within the lock range. Same output equal to input. If I make now B, FB, what will the output of a, is it a FB or F0? When I make to the B, FB is above the FL1, FL2. So it will go back to F0. So this is an important point which you have to understand. Thank you. Now let us go to this free running, capture and lock range. There are three states are there. Free running frequency means F0, what I told. Capture means just now we have discussed FC1 to FC2. Lock means FL1 and FL2. In the free running state, either there is no external signal or feedback loop is open. Capture range, to be the capture state, there must be an external signal and the feedback loop must be closed. Then only there is a chance of capturing. So actually this is very interesting, and I told some people are doing a PhD on this, and it takes a lot of time to understand in depth. But this much what you understood is more than enough as of now for your syllabus. Then let us go to the next. This is a block diagram for a 565 PLL block diagram. What we have discussed now: phase detector, amplifier and voltage controlled oscillator. I have to give the feedback. Therefore, whenever I am conducting any experiment, I will short pin number 5 and 4 so that VC output I am giving back to the phase detector. Phase detector will compare input frequency and this frequency, it will give the error voltage. So this is how 565 works. It is the same block diagram what you have taken within the IC, that's all. Now PLL compares F1 and F2, it will give the error voltage, and error voltage is directly proportional to the difference between these two frequencies. And if the frequency difference is little more, voltage will be more. If it is equal, voltage will be 0. If F1 is greater than F2, for example, positive I am getting. If F1 becomes less than F2, I will get a negative voltage. Like that, error voltage I will get, and that voltage is amplified and is given to the voltage controlled oscillator. And electrical characteristics of a 565 PLL, operating frequency is up to 500 kilohertz you have, and range is 6 volts to 12 plus or minus. And input voltage what you give, it is a 3 volts peak to peak, maximum we can give. Okay, 10 millivolts is the minimum. You are supposed to conduct the experiment, and these are the points you have to remember when you are conducting the experiment. It's very interesting to see the lock range and capture range in the when you are conducting the experiment. It's so interesting. Anyway, if the time permits, these are the equation. How I will get a F0 equation? F0 is given by 1.2 by 4 R1 C1 Hertz. Based on the R1 and C1 values, we will get a F0. So you can choose a particular F0 so that center frequency you will get. And FL, what is the lock range, sir? If I take a F0, so 8 F0 divided by V, this much of Hertz lock range I will get. And capture range, FL by 2 by 3.6 into 10 raised to 3 C2, these many Hertz will be the capture range. And most of the time we ask the students to calculate theoretically FC and FL and find out practically whether are you getting same or not. Most of the time a small variation will be there whenever we conduct the experiment. Lock range manually what we are calculating using equation, and practically what we are going to observe in the CRO, a little difference will be there sometimes when you conduct the experiment. And applications are there. Frequency multiplier. So frequency multiplier, simply it's a block diagram only what you have taken. Extra is divide by n network. So those who feel difficulty to understand, it's very easy to understand. So let us consider it as a 10 kilohertz. I have given one numerical example. Now divide by 5 I will do. This will become how much? 2 kilohertz. So input I am giving 2 kilohertz. So automatically these two are, this is 2, this is 2. This is the error voltage is 0. Automatically it will become 10 kilohertz. If the small variation is there, for example, input voltage little increases, automatically this will also increase. So multiplication into 5 because I use the divide by 5 network here. This is one simplest application of a PLL, okay, a frequency multiplier. And frequency keying demodulator, FS key. All of us know, we have discussed. This phase detector will compare F0 and whatever the input I have given. If I give a FM signal as an input, no doubt frequency is varying. For example, 2 frequencies are there, FSK means. So automatically 2 voltages I will get, that will become my error voltage, that I can take it as a demodulated output from the PLL. So this is another application where I can use a PLL. And a frequency synthesizer, it's nothing but I will use not only divide by n, I will multiply here, by varying m and n, I can get a different frequencies. That is a name we give, frequency synthesizer. I will get a different frequencies. I can use a divide by n and divide by m. I will change the m and n. The way how I have shown you people divide by 5 when 10 kilohertz was there, I could able to get a multiplier. Like that I can have a divide by m and divide by n. I can get a different frequencies from this IC. So that is another application you have. Determine the free running frequency, lock range, capture range. They have given the circuit. I know the values and equation I know. Simply I will fill the values in the equation and I will get a capture range as well as lock range. The procedure we have you have given in the sheet already, how to conduct the experiment. And if you want, this information will be available to you. People can go through how to conduct the experiment to find a capture range, to find the lock range, free running frequency. That information will be available to you people. And I told many students are sending emails, and this is sample emails I am sharing with you people. I have seen the videos of yours YouTube regarding the capture range and lock range. I have a doubt if the phase or doesn't match with the PLL. I thought these people are students of some BE engineering college, but later I came to know that these people are doing PhD on that. So then I told it is better to discuss with the person who has done a PhD in this PLL only. See, my name is Divya, I am from Madurai, something they are telling. They have completed my MTech in VLSI, currently doing a PhD in Vellore Institute of Technology, one of the best college you might have seen, Vellore Institute of Technology. She is doing a PhD on PLL. So you can imagine how much this particular IC is important. So she is doing a PhD on PLL. Then I gave her 2-3 numbers, those who had done a PhD on PLL only. They have taken 5 to 6 years, and their numbers, their cell numbers, their contact details I gave to her. And many people, they are asking a lot of doubts related to the PLL. I am getting emails now also, but not engineering students, they are all doing a PhD. Okay, see, somebody is telling I am struggling to understand the PLL bandwidth. Like why is it divided by 10, why is it including the frequency? They definitely, it's not so easy to understand. Okay, capture range, lock range, and many emails now also I am receiving, many emails, and many people are doing a PhD on A to D converters, successive approximation, and dual slope, and PLL. All are PhD topics. It's not a just 10 minutes topic. Many people are doing a PhDs. Okay, and this is the end of the PLL topic. This is the end of the whole syllabus.